This kid, Michael Satterley, he sold $300,000 of this thing last year, and I'll just go ahead and let him demo it.
I'm 6 feet from the edge and I'm thinking.
So we bought one and took a look at it, and you know what? It might be able to be improved a little bit more. So I was fascinated by this. This is a fully 3D printed product. He's a kid on TikTok. He's built out a print farm. He's grown a business. It's doing amazing. But then I saw this. He had this listing on his website for a steel version of the Cruise Cup, which means that he's taking it to China, which means that he's not using his print farm anymore. And I just can't let that stand in good conscience as one of the people running a big old 3D print service. He's trying to abandon 3D printing, but why? Because 3D printing isn't scalable. Because 3D printing cannot make durable parts? Well, that's not true. We could knock out 3,000 to 10,000 of these things per day inside of our print farms without even breaking a sweat. All Cruise Cup would have to do is plug in a teleport, and then we could start printing them tomorrow. And with good design practices and a standard type of product, you can have it last as long as you want to. And very clearly, the customers don't care, because customers are the only definition of quality and durability that you ever need. They're selling these things, which means that customers must like them fine. But let me dive into this a little bit more and prove how this could be made as durable as anything else, just by showing you how you would design it so that it could last for years. So, as I mentioned before, this part is made of 3 3D printed parts. You have a bottom, a top, and then this main center tube part. Honestly, I'm not a fan of this. Having 3 separate unique parts inside of an assembly is a lot more effort than it's worth, because you can actually have these parts combined all into one. 3D printing lets you create any geometry you want. Now, I get that Cruise Cup is probably doing this so that number one, these can all be produced on one machine, these can all be produced on one machines, and maybe they even had a plan to replace this tube with a piece of acrylic or something at some point. So I get that, but it's still a challenge because you have this bit of assembly at the end of each one of these things, and you don't need to have it. An assembly, whenever you can avoid it, needs to be avoided. Plus, with the 3 separate parts, you now have 3 things that have to be produced in order to get it out the door, rather than just knocking out one of these cylinders each time. So I have gone ahead and redesigned it. So the first thing we had to contend with was actually the tabs at the top of each one of these rings. These tabs are actually 3D printed themselves, which was surprising to me when I was first looking at the Cruise Cup, because you would think that these would be like a flexible rubber or something else in order to get that grabbiness that he has with the cans whenever he's launching them, like this. But they are 3D printed. They're about a 1mm thick flange inside of there that is printed horizontally like this. Now, this is generally a point of concern because the layers are going this direction and the tabs are flexing this direction, which means they can fatigue along the layer lines. This may be happening out there in practice, but there's a few things that are working for them. Number one, they have this outer ring that prevents the tabs from flexing too far, and the tabs themselves are designed in such a way to where they are actually longer than they appear. Since they're not perfectly vertical, they're actually curved. You have more distance to spread that stress concentration over, so they may be holding up just fine. This part also appears to be made potentially out of a PETG, kind of by the way it's printing there. The cooling fan might be a little bit high, but that's all right. But even so, even though these tabs seem to be working okay, I would like to push them a little bit further to where they can never fatigue, because even though they won't fatigue for a while here, they will eventually break, wear out, and let those things snap off. And they sell these as spare parts, which is fair and decent of them. Like, they do nothing to say that this isn't 3D printed on their website. They go ahead and tell you that it's printed, and again, so long as the customer doesn't care, it doesn't matter. But then how did I go ahead and fix this with my design for this whole thing? Well, if the issue is that these things are going to bend across here perpendicular to the layer lines so that they eventually snap off, the trick is to not have them bend along the layer lines. These things have a way of flexing in the horizontal. If you're bending along the layer lines, if you're like squashing a part like this, it will hold up forever because those individual layers are actually almost better at dealing with fatigue than a traditional part because cracks can't propagate through the layer line. So rather than having it bend from the bottom, let's go ahead and have it bend from the side. Now, this is a little bit tough because you have to get into some complex modeling, but what I did was I made fins that have a single base that is connected to the bottom of the cylinder, and then they splay out from there. That way they are bending sideways, but they are supported underneath. If I was just trying to do a standard flap, like a grip fin sticking straight out there that just is coming through the circle like this, then you would have support underneath it, which means that the can can't feed through, and you have all kinds of weird shenanigans. And these are things that you just don't want to have to deal with. From a manufacturability standpoint, when a part comes off the machine, you want it to be done, ready to go. No assembly, no support removal, no post-processing. Hit it with a heat gun and leave. And that is what this type of a design Redesign does. This lets the whole assembly be done in one go, and the fins don't need any support or any weird post-processing. And now each one of these fins can bend as far as we want it to, and we can change how stiff they are just by changing their thickness. And by changing their thickness, we don't make them stronger or weaker at all, because again, you're not dealing with it bending across the layer lines. Cruise Cup has to make these tabs almost as thick as they are, which may be good or bad. It's good because it's strong and it holds up well, but it might be bad because they might want to have a lighter touch on how this thing works so that you can eject the can easier. Some 13-year-old girls like to drink Dr. Pepper too. But effectively, by designing these tabs like this, we have eliminated the fatigue problem down to just the ability of the material. It no longer has anything to do with whether it's 3D printed or not. These will last as long as this material is able to hold up. Now let's get on to the actual tube itself, this core body that the can is held inside of. Now, when I initially saw this as a 3D printed center tube, I thought when we were designing our own version, maybe we should just have the end caps and then have an acrylic tube in the center. That way, instead of having a 3D printed tube, you can just use stock material and then you cut it up and then just cap it off, and then you've got a cruise cup ready to go. But the issue that I had with that was that it doesn't really take advantage of printing, and you still have assembly. If you're using acrylic, you can no longer screw stuff together, you have to then glue it together, and you lose a lot of flexibility because, say, you didn't want this to work with just a standard can. You wanted to work with like a monster can or a White Claw or any of those other types of different sized cans. Maybe your Liquid Death. But then you're needing to change the size of the tube. But if you're producing 300,000 worth of these per month and you want to scale up, having to change out your supply chain for any new variation can be a challenge, because now they have to store up a bunch of tubing and then they have to cut it up and then they have to assemble it. It adds a bunch of steps. Whereas if you just design it to be 3D printed, well, it just comes out with a 3D printer. And then if you create a new SKU, well, it comes out on the same 3D printers. So the business model actually enables this a lot more, but it has one more advantage. If you were using a tube, the only way you would have of marking it would be to like put a sticker on it or something along those lines. But with printing, you can go ahead and just add those types of features straight onto it, and you don't have to worry about a thing. So now you can get all your variation. You don't have to change your supply chain, everything. You just change your digital model. And this goes even further. Rather than simply having a batch with a custom adjuster, you can actually have individual pieces. It is possible to build configurators where you just upload a logo and then a person can stamp their name across one of these things, and now everybody can get their Yeti that's holding a couple of cans. So having the tube be 3D printed is a great idea, and it works really well for the business model and lets you scale up through customization and all types of new items into the future. And if you're using large-scale print farms, it doesn't add any extra work to you because, again, all you do is update the digital file. So now what we have done is we have made the fins last forever so that you never have a part wear out, so that people can just buy a whole new one to get them in different colors and that kind of thing. But you still have the same functionality, and you eliminate all the assembly because there's no longer 3 separate parts that have to be screwed together. You just have one single part, and you don't have to worry about any of the other problems that come along with the manufacturing, and you can just keep on knocking these things out. This is such an amazing product, and I am so proud of Michael for what he's been able to do by running with this thing and just knocking out TikToks and getting as many of these things sold as he possibly can. Because it's a great product, it's super demonstrable on video, and it can be improved even more. So, but yeah, Michael, you don't have to go to China and start making some steel thing. You can get these things made. You can get 10,000 of them a day if you need them. And you don't even have to run the print farm anymore. There's the stuff out there like Teleport where you can just upload the file and then you get 1,000 machines in your pocket to knock out these types of parts. So don't go to China, don't go to all the steel shenanigans and working with supply chain, because tariffs are gonna whack in a minute anyway. Just stay within 3D printing because it gives you a ton of advantages. You get rid of all the assembly, you can still make a fantastic product, and you can create all kinds of new value that no other product can even touch because you have a manufacturing process that can do something that no process has ever been able to do before. So for any of you watching, if you want to get a hold of these files, they are available for free inside of the Teleport catalog. We will link to it down in the description so that you can start selling our versions of it if you ever want to. But those files are available for all Teleport users so that you can just add them to your store tomorrow and they immediately start getting produced and shipped out for you. But beyond that, thank you all so much for watching, and comment below any other sort of viral products that you think might need revamped or redesigned. Have a great day, everybody.